Practice problem 8.5 millimeters, grams and seconds. Part origin is located at the center and the bottom. We have lines, circles, center lines, lofts, extrude boss, extrude cut, and circular pattern. The loft is between two circles. All right, so let's go ahead and zoom up a little bit on this and see if we can get a little better detail. I'm not sure why this needs to be a loft. It kind of goes towards could just be a revolve, but I think part of this too is just going to be looking through, being able to see through the noise. All right, so got a couple different scales going on too. So detail B is the bigger, and detail A is the smaller. So we've got to come up with some way. So that's the undercut and the boss. So those are a little bit taller. And so let's see. So that face to that face, and then the undercut or the relief back to that geometry and up both sides. All right, let's go to 10 millimeters, 30 millimeters, 25, 45, 15 for the square. And then what do we need for the outside? 55 and 48 going to 27. And the height then goes 5 millimeters to the step and 9 millimeters to the top of the base. All right, well, let's get started with that. And we'll see where that goes. We're going to start in the top plane. And we'll go with the 55 millimeters to the outside and extrude it up 5 millimeters. Okay, so that gives us a starting point. The circle then at the bottom, and again, I probably would have, if they didn't show a loft or recommend a loft, and we weren't actually detailing a loft or introducing it, then I probably would have just done this as a revolve. All right, so the right plane, nope, we need to still be in the top plane, hold down the control button and select the plane, drag up. We have an offset distance of 5 and 19, so let's just go with 14, make that easy. And then we'll go with a sketch on that plane that goes to 27. All right, so kind of like the sweep, we need to have two sketches, or in the case of a loft, two or more. And what that's going to do is calculate the geometry between. So if this is just a straight line and it looks like a revolve, then we're okay. The where the loft would really become handy is if maybe this had a bulge or shape, or these were elliptical and we couldn't do them with those shapes. So let's go to the lofted base, and we're going to do sketch 2 to sketch 3. And I don't really want to move these because I think they're probably in pretty good shape along the right plane. And if we move this, it's going to start to twist and do some strange things. Could always do a guide curve from point to point. And that's one way. There's other methods that we could possibly work with to manage the circles. All right, so what do we have for a bolt circle? 45 degrees. We have to the outside. So let's go back. Well, we can either pick the bottom or go to the top plane. Doesn't really matter. So let's open up that sketch, and we'll go ahead and put in the geometry. Since I don't really have anything to build from, let's see, that diameter was called out as a 13. Okay, and I'm not too worried about the geometry for the hole and the cut yet. So we previously tried to do the vertex, an endpoint, and a point, and now it gives it to me. So I'm not sure what was going on with that geometry, but if if I needed to, I could have put a point up here and just picked between 3 points. Um, or if I wanted to go with a line, I would need to put another center line, and that would give me an angle between the two center lines. So there's an angle off of the back side. I wonder if they're going to try to blend that. No, it's just off of actually it's off of the other side. So let's take a look. This has a lot of noise in it. So 13 off the back. I'm not really seeing anything that indicates a center. Well, it's sort of. Yeah, and it's another one of those. Let's kind of go over this way. So yeah, it's looking like the 55. Okay, well, we're going to go with the bolt circle is the outside or the perimeter of our circle. So get out of the dimension by hitting escape. Okay, make sure that I'm actually out of the escape. All right, let's go ahead and just drag it then. And we will go ahead with a circular sketch pattern. We have the 4. Didn't really let me put that in, but let's then dimension the radius. See if actually that one should already be there too. So let's just get the 4 in there. And then we can drag away, drag back, pick one of the other ones, drag away and drag back, and that'll give us our fully defined. All right, so I drew that on the bottom. It went normal too. So that geometry then got called out on the step to a height of 6. All right, let's make sure. Yeah. So 6, and pretty sure those are going to be the steps. So I'm not sure why they would do that. Makes the machining at this intersection more difficult, but and if we're actually manufacturing, or if this was a casting 3D printing, we wouldn't care so much. And would help to go the right way. So let's edit the feature again, flip the direction, and go ahead. All right, so this corner to this corner, those will ultimately need radiuses or something else if we were actually going to manufacture this this piece. All right, so our diameter then, we have the steps. So let's go to the top plane and you'll see the difference that the top plane comes back this way. This is going to cut in, or this segment is going to cut in on each side into the end of the base. So let's see, they're giving us center line of 22. So let's start it somewhere. We'll get close to vertical. And the exterior is a diameter of 30. And let's just go 22. Okay, and then the last will be to make the center point and the origin vertical. Do I want to go ahead with the rest of the items? My tendency, if I was just drawing this, I would probably put the other circles in so that I could reuse that sketch, but I think I'm probably going to end up with just too many selections there. So for this one, we're going to go ahead and extrude and bring it up 36. Open up the next sketch and find our center. So if I don't find the center, I'm dragging over the perimeter. And we need a dimension of we went 30, and then we're going to have 25, and that is going to go up 1 millimeter. Yeah, I think this is going to work out better too because these are all chained together, one on top of the other in the dimensions. If it was baseline, we'd probably have a better, we'd be better using the shared sketch. So this one goes to 15, and then we're extruding it out to 29. Okay, just kind of double checking the numbers as I go. Open up the next sketch, goes to 13. And extrude. And then that one goes 5, and we'll accept. And then the last sketch goes to a diameter of 10. And features extrude, and then also 10 millimeters. All right, couple enters to clear that out. All right, so I think we're looking pretty good. Let's do a reality check. So this backside has a little relief or an add-on. 35 degrees tangent, tangent. So we should be able to do that. Probably end up just converting that geometry. So we're getting close, need the block in the center. Don't want to forget that. So let's go top plane and sketch. So when it comes back around, I'm not trying to reverse or manage that geometry. So let's go with our shape. We had an angle of 35 from the vertical. So rather than doing math and figuring out what the adjacent angles are, I can put in a center line and set the angle. Let's see, did I get a tangent? I got the coincident, but I did not get a tangent. And then the fillet is going to be radius of 6. So let's go ahead and put that in there. And then we need to accept. Let's pick and convert. And then with the convert, it'll probably be a little easier if I drag those endpoints back around and just make it a complete region. So extrude, and I'm going to do up to surface since it should have the same height as this step, or in my design intent, I would like it to have the same height. All right, so on the rectangle then, let's go ahead and select the midpoint, the origin, make it vertical. We have a width of 15. And where is it positioned at? Actually, looks like, yeah, it's going through the center. All right, so didn't need to make them vertical. So we'll just go ahead and switch it to midpoint. As long as there's not a conflict there, the vertical won't really do anything. And then I happen to grab coincident apparently. Yep, grab coincident on one side, which since it ends up subflush to the surface, I don't know that that's a necessarily a bad thing. And we're going to extrude this to 20. Oh, I guess it would help to put it back in blind, 20 millimeters. And okay, any radiuses, fillets, blends on that? Okay, now we can concentrate on these guys. So let's do the convert again, and we'll use that drag. Probably would be a toss-up. Okay, so once we convert the entities, probably be a toss-up to just drawing the circles again. But since they're tied to that geometry, it does kind of help to build that out. So let's go ahead and extrude cut, reverse the direction up to next, go ahead and accept. All right, so that's looking pretty good. And then our last bit of geometry that I can tell is going to be the diameter of 5, and those are centered. So we drag over the edge, find the center point. Yep, let's make sure to place it. Well, didn't want that one, so I'm going to give it a Control Z. Yep, kicked me out. All right, and we'll go back in. All right, all of these are going to be equal then. And we'll go into the dimensions, set it to 5, and extrude cut. And we'll go back to through all. All right, so a quick look at the geometry in our isometric. And that looks pretty darn close. We've got the little elliptical reliefs, the little fingernail cutouts, and the shapes. We can go to a to maybe a top view, and yeah, that comes over to a sharp. So, you know, again, looking at this manufacturing wise, these wouldn't be sharps. These would have additional radiuses, or we would have to do some more on the blend. And usually a spot face like this would be subflush of this surface, not proud of it. All right, so anyway, we've got our list of our features. Let's go ahead and save this as 8.5. And our volume then, I usually put the dashes, so we'll do a rename on this one just to really go back through the process. All right, 53,816, and we had a number of 53,816. So did pretty good with that one. We'll save it, and I don't like going back to the DOS days. We didn't put we didn't put periods into the to the name, and even though the latest Windows don't really seem to mind, it's not a preference of mine. So get into the habit of when you rename anything dealing with SOLIDWORKS that you go to the show more options, go to the SOLIDWORKS and do the rename. So if this is used in an assembly, we've already made the drawing, it will update those items. If we're renaming an assembly, then I would want to include virtual components. So that anything that was created and embedded in the assembly has that link, that associativity updated. All right, so it renames the 8-5. It's not a critical step. We could do the single click, single clip, and then next time you open it, if there is an associative location, it will just ask you to go find it. And if there's multiple, it will ask you every time. So, all right, I think 8.5 is good, even though the part was pretty busy and got through it.